Hi guys, today we're going to talk about applications of right triangles. So basically, word problems. Quick little reminder of the Pythagorean theorem, a squared plus b squared equals c squared. We're going to use this whenever we have all side lengths. So if we're given two sides of a triangle and need to find the third, then we'll just use the Pythagorean theorem. Sine, cosine, and tangent is when we also have an angle in there. So if inside the triangle somewhere you have an angle that you have the measure of, then you're going to use trig ratios, sine, cosine, and tangent. If you're actually trying to find the measure of an angle, then you're going to use inverse trig, sine inverse, cosine inverse, tangent inverse. Cool. So we are going to draw and label a picture, then solve for the missing part, and round the sides to the nearest tenth and the angles to the nearest degree. Okay, so first of all, Ashley jogged 3.4 miles east, 5.7 miles south. How far away is she from her starting point? So, here was our starting point. Real quick, I'm going to make a little compass rose. Never eat soggy waffles. There we go. So first she goes east, 3.4 miles. Then she turns and goes south, 5.7 miles. And we want to know, how far away is she from her starting point at this point? So we want to find this distance right here. So if you notice, 3.4, 5.7, and x, those are all side lengths of my triangle. So since all I have is side lengths, I'm going to use the Pythagorean theorem. One of the main things to remember in the Pythagorean theorem is that C has to be your hypotenuse. So we have a right angle right here when she turned from going east to going south. Across from that right angle is our hypotenuse, or C. So we've got a squared plus b squared equals c squared. So it doesn't matter which leg is A and which leg is B. I'll call A that 3.4 and B my 5.7. If you have those switched, that's totally fine. What matters though is that X has to be in for C since he's our hypotenuse. So what we need to do is we need to solve for X. So I'm going to pop this stuff over on the left into my calculator. We had 3.4, let me move my face, squared, oopsies, squared, plus 5.7 squared. So we end up with 44.05. Equals x squared. So now to get x by itself, we're going to have to take the square root of both sides. So my squared and square root cancel each other out. And then we'll put the square root of 44.05 into our calculator. Square root 44.05. And we're getting 6.6. Since the number after the 6 is a 3, that 6 in the tenths place is going to stay a 6. Okay, so it's 6.6. And our units were in miles. Good deal. There is a 31-foot support wire attached to the top of a 25-foot telephone pole to a point on the ground. How far from the base of the pole does the wire meet the ground? Okay, so let's first draw our telephone pole. Telephone poles usually make a right angle with the ground. They tell me that telephone pole is 25 feet. The wire is attached at the top of the pole and goes down to the ground. And they told us that that wire is 31 feet long. They want to know how far from the base of the pole does the wire meet the ground, or how long is this piece right there? Once again, since we have only side lengths, we're going to be using the Pythagorean theorem. So the main thing to make sure that you're careful about is which one is C. C has to be your hypotenuse. So across from the right angle, there's C. I'll go ahead and put X in for A and 25 in for B. Equals 31 squared for C. Okay. Let's find out what 25 squared is. 25 squared. 625. Oh, should probably move that in a little bit. There you go, 625. And then we have to find 31 squared. 961, okay. So the next thing we need to do is subtract 625 from both sides. 961 minus 625. 336. So when we subtract 625 from both sides, x squared equals 336. So now we have x squared equals 336. So to get x by itself, we'll take the square root of both sides. Square root of x squared, those cancel each other out, so we're just left with x. And then we'll put the square root of 336 into our calculator. Square root of 336. We're getting 18.3. Since that next digit is a 3, my tenths will stay at 3. So we got 18.3. And everything is in feet. Okay. Jake leaned a 12-foot ladder against his house. The angle formed by the ladder and the ground is 68 degrees. How far from the base of the house did he place the ladder? So, let's first of all, here is my house. My house tends to make a right angle with the ground. There's a little bit of grass right there. Then we have this ladder that we were told is 12 feet. They also let us know that the angle that the ladder makes with the ground is 68 degrees. And then they want to know how far from the base of the house did he place the ladder. So we want to know this length right here. This time I have an angle measure, right? So since I have an angle measure, I'm going to use my trig ratios, sine, cosine, tangent. So to use our trig ratios, what we need to do first is label our sides. So across from my angle is my opposite side. Across from my right angle is the hypotenuse. And the side that's left over is the adjacent. I don't have my opposite labeled, so I'm looking at adjacent and hypotenuse. Which trig uses adjacent and hypotenuse? Yeah, cosine. So we have cosine of our angle is 68 equals adjacent over hypotenuse, or x, over 12. Since x is in the fraction, I'm going to put cosine over 1 and then cross multiply. 1 times x is x equals 12 times the cosine of 68. So now we just need to pop that piece into our calculator. 12 times the cosine of 68. We're getting 4.49. So since this next digit is a 9, he's going to round up to a 5. So we'll be at 4.5. X equals 4.5, and our units are in feet. Okay, a ramp is used to load suitcases onto an airplane. If the cargo door is 7 feet from the ground and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? So first of all, we have this long ramp. Lovely. And it says that the cargo door is 7 feet off the ground. So right there is 7 feet. Here's the ground. We know that it's going to make a right angle. They said that the ramp and the ground down here was made an angle of 25 degrees. So that means that this angle right here is 25 degrees. And then they want to know how long is the ramp. This right here is the length of the ramp. So since I have an angle measure, that means I'm going to use sine, cosine, and tangent. Or, I guess, sine, cosine, or tangent. All right, so we got this 25 degrees. We're going to use him to help label our sides. Across from him is our opposite side. Across from our right angle is the hypotenuse. And the side that's left over is the adjacent. Since I don't have a label for adjacent, I'm going to ignore it. We have lengths for opposite and hypotenuse. Which trig uses opposite and hypotenuse? Yeah, we're going to be using sine. So sine of my angle is 25 equals opposite 7 over hypotenuse x. Since x is in the fraction, I'm going to put sine of 25 over 1 and cross multiply. So I'll take x times the sine of 25 equals, and then 1 times 7 is 7. To get x by itself, it's being multiplied by the sine of 25, so we need to divide by the sine of 25 on both sides. So then we'll just go ahead and pop that into our calculator. 7 divided by the sine of 25. We get 16.56, so that means this guy needs to round up to a 6. So 16.6. And we're in feet still. All right, so let's have a conversation about angle of elevation and angle of depression. So it's all about from the horizontal up or from the horizontal down. Angle of elevation obviously is going to be up. So it's when you're looking up at an object from the horizontal. So let's take a look at an example. A dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up the tree. What's the angle of elevation from the dog to the cat? Okay. So we have a tree. Ain't it beautiful? There's a dog 5 feet away. There's a cat up in the tree. And the problem says that he is 16 feet up there. This right here is the line of sight, the dog looking at the cat. So they want to know the angle of elevation. So from the horizontal up, So we want to find this angle right here. So since we're trying to find angles, we're going to use trig, sine, cosine, tangent. So we'll label up our sides. Across from my angle is my opposite side. Across from the right angle is the hypotenuse. And the side that's left over is the adjacent. I don't have a label for hypotenuse, so I'm looking at just opposite and adjacent. Which trig uses opposite and adjacent? Yeah, tangent. So we've got tangent of our angle. We don't know what it is, so we're going to put an X equals. Tangent is opposite over adjacent, so 16 over 5. So we want to get rid of tangent to get x by itself. So we're going to take the inverse tangent of both sides, or that tangent with the -1 on it. Inverse tangent and tangent cancel each other out since they're inverse operations, and we're just left with x equals. Then we need to put the inverse tangent of 16 divided by 5 into our calculator. Click over here in function. Inverse tangent 16 divided by 5. Ended up with 72.6. It said to round to the nearest degree, so since there's a 6 there, this guy will round up to 72. 72 degrees. All right. Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? Okay. So, here's our lighthouse. That's 84 feet tall. Now Casey over here is chilling. He or she, they, is looking up at the top of this guy. And right here is our horizontal. So from that horizontal up is 58 degrees. Now we know Casey is 6 feet tall, so this length right here is 6. We want to know how far is he from the base of the lighthouse. So this guy right here. Now, I want to look at just this green triangle here in a moment. We've got that 58 degrees, and we've got x. We need to figure out how long, here we go, is this purple part. Well, we know this piece right here, obviously not to scale, is going to be 6, right? So if we take 84 minus 6, we'll end up with 78 for this length right here. Now we're going to look just at that smaller triangle. Here's my right angle. Across from the angle that they gave me is the opposite side. In fact, I'm going to go ahead and cross out that 84. We don't need him anymore. Across from the right angle is the hypotenuse. And the side that's left over is the adjacent. The hypotenuse isn't labeled, so we just have stuff for opposite and adjacent. Which trig uses opposite and adjacent? Yeah, tangent. So we've got tangent of our angle is 58 equals opposite over adjacent, so 78 over x. We'll pop the tangent of 58 over 1 since x is in the fraction, and then we'll cross multiply. X times the tangent of 58 equals, and then 1 times 78 is 78. To get x by itself, we need to divide by the tangent of 58 on both sides. So we'll have 78 divided by tangent of 58. And then we'll pop that guy into our calculator. 78 divided by the tangent of 58. Good deal. We're getting 48.7. And since that's a 3 afterwards, he's going to stay a 7. 48.7 feet. Sorry, that one got a little messy. Okay, angles of depression. So an angle of depression is from the horizontal line of sight down. What I tend to do with angles of depression is I make a rectangle out of everything, just to make everything a little bit easier to find. Another thing that is a good thing to know is that our angle of depression right here is going to be congruent to that angle of elevation. So that angle of elevation from the horizontal down, from the lifeguard to the swimmer, is going to be the same as from the horizontal up, from the swimmer to the lifeguard. So, just fun fact. All right, so a lifeguard is sitting on a platform next to a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? Okay, so first of all, he's sitting on a platform, looking down at the swimmer in the water. Okay, so here's our platform. Up here is our lifeguard. His line of sight is 8 feet above the ground, so that length right there is 8 feet. Here's my horizontal. Over here will be my swimmer. There's the lifeguard's line of sight. So the angle of depression from the horizontal down right here is going to be 18 degrees. How far away is the swimmer from the lifeguard tower? Actually, I want that piece. Cool, so here's what I like to do. I like to go ahead and make myself a rectangle. I know because of how rectangles work, opposite sides are congruent. So since this side is 8, I know this length is going to be 8 as well. So now what I'm going to do is just work on my green triangle. So I'm given an angle, I need to use trig. Across from my angle is the opposite side. And across from the right angle is the hypotenuse. And the side that's left over is the adjacent. Adjacent isn't labeled. So we're just looking at opposite and hypotenuse. Which trig uses opposite and hypotenuse? Yeah, sine. So the sine of my angle was 18. Come on. Here it goes. Equals opposite over hypotenuse, so 8 over x. Since x is in the fraction, we're going to put the sine of 18 over 1, and then we'll cross multiply. X times the sine of 18 equals, and then 1 times 8 is 8. To get x by itself, we would have to divide by the sine of 18 on both sides. So we'll have 8 divided by the sine of 18. Now all we need to do is pop that into our calculator. 8 divided by the sine of 18. We're getting 25.88, which means this 8 is going to round up to a 9, 25.9. And that is in feet. Good deal. Building A is 480 feet tall. Here's building A. Then there's building B, and he is 654 feet tall. The angle of depression from the top of building B to the top of building A is 42 degrees. So here's that line of sight. Here's our horizontal. From the horizontal down is my angle of depression. So that's going to be 42. Good deal. Okay, so I'm going to make myself a little rectangle right here, and we can do some problem solving. So we know that building B is 654 feet tall, and building A is 480 feet tall, right? So right here is the difference in their heights, right? So that means I need to take 654 minus 480. So 654 minus 480. 174. All right. So we now know this piece right here is 174. I'm actually going to erase that to get it out of the way real quick. There we go. That means that over here, this side is also 174. We want to know how far apart are the buildings. That's going to be the same distance right there. So I'm going to look at just the purple triangle. Across from my angle is the opposite side. Across from the right angle is the hypotenuse. And the side that's left over is the adjacent. I don't have anything for my hypotenuse. So which trig uses opposite and adjacent? Yeah, tangent. So we have tangent of our angle, which was 42, equals opposite over adjacent. So, whoops. 174 over x. Don't know what just happened. Okay, let's just solve this so that way we can move on. All right, so we'll cross multiply x times the tangent of 42 equals, and then 1 times 174 is 174. To get x by itself, we need to divide by the tangent of 42. And then we just need to pop that into our calculator. So we'll take 174 divided by the tangent of 42. We're getting 193.2. So they are 193.2 feet apart. All right, good deal. See you guys a little bit later.